So hi guys, welcome to the session again. We'll be looking at the Python code for polynomial regression. What we will be doing is we'll be going through the code, and I have also put in comments for all the new lines of code which we have added, which was not part of the linear regression code, right? So this is the simple step where we import everything which is needed for us to run the polynomial regression. So these are the module training test data. The additional bit that we have done is this line, right? Polynomial feature to generate polynomial and interaction feature, right? And moving on to this, here we have created the sample data in this line. We'll and then we train and test the data. X train x test, y train y test. This is a module, right, which can split the data into training and testing. Testing size for 20% and training is 80%, and then we do the random state as 42 so that it becomes consistent across. Then we do the polynomial is degree 2. If you look here, x to the power 2, then x square, that is the degree. Then we fit and transform first the training data. Here we are fitting the training data, then we are fitting the test data. We are fitting a quadratic polynomial, right? Quadratic is to the power 2. Compute the polynomial for training data, applies the same transformation to test data. So we are basically fitting the polynomial feature to this test data and the training data, right? Then we use the linear regression model, because a polynomial regression is part of the linear regression, right? Then what we do is we fit this data. So x now here becomes the polynomial equation. Y is your actual training data. Y has remained as is, even though relation is the polynomial. After transformation, it becomes linear in the new feature, right? So fit train the model. Then we do the same for prediction. So this was done on training data. Is done on prediction data. Sorry, I am not running the code. Let me quickly run it across. This is a simple Python code. It's not much needed. Then we plot the graph. If you look at this, there's a relationship that has been built across the. Okay. Additionally, the additional notes as well. You can change the degree. Here we have put the degree as 2. You can move it as 3. You can have to write another equation here, x square x to the power cube, right? And then you can work across it. Let me just change the degree for you guys and see what happens, right? Look at this. This has moved around. If I do 5, where is my quadratic degree polynomial? 5. Let me then run it. Okay, nothing is changing because I am not changing it over here. If I change it over here, it will start changing, right? That is the reason it is not changing. If I put another equation, 0.6 into x to the power 3, that is to power 3 plus. Now so just look at this graph now. Now this polynomial equation has become to the power 3. I'll use 3 over here. Let me run this now, see what happens. Look at this, the graph has changed, right? So this is what we are talking about. So I think this was useful. We'll go through the other regression models in the coming lecture. Yeah, thanks for your time, guys.